This is video 3 of Unit 1 of our notes. In this portion of the video, we'll actually talk about matter, and we'll do some calculations with matter. So it's a good idea to define what matter is, since this class is all about matter and change. And matter is anything that has mass and takes up space. So these two things must be present for something to be defined as matter. So for example, a common question is, how about air? Is air matter? So can we take the mass of air, and does air take up space? Well, if you have a cup and you cover the cup with something, we think that the cup is empty, but in fact inside the cup are a bunch of air molecules. There's a bunch of oxygen, there's a bunch of nitrogen, some carbon dioxide, and some argon in there. There are about 4 gases that are actually inside the cup, and they definitely take up space, so air definitely is matter. The question whether you can take the mass or weigh air, you can actually weigh air if you do it right. Air is able to be weighed. So if you take a bottle, for example, you'd have to pressurize the bottle. And if you can increase the pressure inside, just add a bunch of air to it, you'll see that it weighs more after you added the air than it did before. Now, how about some things that are not matter? Some things that are not matter would be energy. And energy comes in different forms. You can have heat, for example. You can have light as energy. These are not considered matter. You cannot take the mass of heat. Heat doesn't take up space, so these would not be matter. Information is also not matter. Information is something that's real, but it is not matter. So thoughts, for example. Thoughts are real. We can't really, thoughts don't have any mass. If you're thinking really hard, you don't weigh more, and thoughts don't really take up space. So that would be 2 examples of things that are not matter. Now this brings us to density. The big lesson for the day will be over density. Now density is how dense something is. If you think about, well, how dense is something? So here I have 2 blocks. In this block at the top, you have the particles. We'll say that this is matter, spaced out much more. So there's more space between them. So this would be less dense. And in the piece of matter down below, the particles, the matter is closer together. So being closer together, we call this more dense. Now oftentimes, the way you can check if something is more dense or less dense, you can check it in reference to water. Water has a density of 1. Density of water. And anything with a density less than 1 will float, like this sphere. Anything with a density more than 1 will sink, so this one would actually sink. Now both of these are actually made of the same material. These are both steel spheres. This steel sphere is solid, so there's no air on the inside, but this steel is actually hollow. There's actually air on the inside. So what they've done is they've spaced out the metal so far that its density dropped to less than 1, and it's able to float. This is how ships float, and boats, partly, big ships especially, and because the density of that ship is then less than the density of water if you take the overall ship together. So let's do some calculations and some definitions with density. So first of all, the definition of density, it has 2 measurements that we'll make in 2 units. Mass goes on top, and volume goes on the bottom. So density is mass over volume. So how dense something is how much mass you have per how big it is per unit volume. So the bigger a substance is in terms of volume, and the less mass it has, the less dense it is. And the smaller the substance is, and the more mass it has, the more dense it is. Usually we use units of grams on top and milliliters on the bottom. So a shortened version of this equation is density equals mass over volume. Now it's really important to be able to rearrange the equation. So I will show you how to rearrange the equation. But in this case, if you have, so we're going to set this as density equals mass over volume. If you have to solve for mass, for example, you have to do an equation where you're solving for mass. The question is, mass equals what? How do you rearrange these variables to solve for mass? Do you multiply the density and the volume? Do you divide the density by volume? Is it volume divided by density? And the answer is from math or from algebra. What you do, so we have density is mass over volume. The rule is if you want to move volume to the other side, which is what we want to do, we want to move volume to this side because I want to solve for mass. I want to have mass by itself. You do the opposite of what's being done now. So right now volume is being divided. So to do the opposite, you would actually multiply. If you do it on the right side of the equation, you've got to do it on the left side of the equation. So what you'll end up doing is multiplying volume on both sides. On this side, the volume cancels out. If anything on the top and the bottom, it cancels out. And you're actually left with this equation right here, which is mass equals, mass would be volume times density. So this is your rearranged equation. Now, if you want to do the same thing and ask, all right, what is volume? Volume equals what? We'll do the same thing. So we've got this equation, which is volume times density equals mass. And now I've got to solve for volume, which means I have to get rid of density. I've got to move density to this side. The same idea follows. Since density is being multiplied, you would do the opposite. You would actually divide by density. So if you do it to this side, you've got to do it to this side. And your equation turns out to be, because these two cancel out, you got volume equals mass over density. So here we put volume equals mass over density. And this is your third equation. So here you have three equations. The original equation, rearranged for mass, rearranged for volume. You should be able to do this because we will be solving for the different variables in the density equation. Now here are some values for some different densities of different material. We've got helium and oxygen. Helium is one of the least dense materials out there. There is a material that's less dense than helium. Notice the units are grams per milliliter here. So notice these are both gases, which means they have really low densities. Oil also has a lower density. This is why oil will float on water. If you pour oil into a glass of water, it'll go to the top. Water is defined as 1. And then we have some really dense material here. Mercury, which is a liquid, is really dense. Gold is one of the most dense materials out there on the periodic table, extremely dense. Copper is about half as dense as gold. We have zinc, that's a little less dense. And here we show ice, which is frozen water essentially. And notice that ice has a smaller density than liquid water. This is why ice floats in water. Here we have a picture, a really interesting picture of this. Here is actually brass, which is copper, mostly copper. And the copper is placed in liquid mercury. So this right here is actually liquid mercury. The symbol for mercury is Hg. And if you throw the brass cylinder in the liquid mercury, it floats. That's because mercury's density is greater than copper's density. So anything that is less dense will actually float in a substance that's more dense. So this is an example of two really dense materials, but one still floats in the other. Now, anytime we express density for solids, we'll use centimeters cubed. So centimeters cubed for solids, and it's going to be grams per centimeters cubed. For liquids, we'll use grams per milliliter. And then for gases, we'll use grams per liter, because gases are really expanded, really low density, so we'll use liters, a bigger volume, to express the densities. Now, you'll notice here that it says a milliliter and a centimeter cubed is actually equivalent. If you take a centimeter and make a cube out of it, so it's 1 centimeter on every side, it will have the same volume as a milliliter. So those are actually equivalent. It's a good thing to know. And here this is kind of shows you how gases are much more expanded. Liquids and solids usually have really close densities. So a liquid, for example, could have a density of maybe 2.5 or something. And the solid version, usually solids are a little more dense, so maybe the solid would be 2.8. But the densities of liquids and solids are going to be really close to each other. There are materials where it's flip-flopped, where the solid is actually less dense, like with water, than the liquid phase. But gases usually are much different, about 1,000 times less dense. About 1,000 times less dense than liquid and solids, and that's why for gases we use liters, which is 1,000 times bigger than a milliliter. Hopefully that makes sense. Alright, why don't we do some example problems. In this case, we're asked if 12.9 grams of aluminum, here is aluminum for you, for your visual pleasure, a chunk of aluminum, has a volume of 4.8 centimeters cubed, what is the density of aluminum? Now for this, we're going to use our first equation. So ask yourself, which equation are we using? We're using the first equation, which says density is mass over volume. And it's as simple as plugging in the numbers into the equation. Now this right here is the mass, and this right here is the volume. So what we've got is 12.9. You can go ahead and put grams divided by 4.8 centimeters cubed, and go ahead and take a second, plug those into the calculator, divide them. Let me do that with you. 12.9 divided by 4.8 gives you 2.69. So we'll do that. We'll round it to 2.7, and I'll talk about how we round and why we round to only two numbers in this case. So 2.7. Now, anytime you put a number down, remember you have to put a unit down. And in this case, the unit is grams and centimeters cubed. So we'll actually use both of them. So the unit for density is grams per centimeters cubed. And this right here is the density of aluminum. Aluminum is actually has a low density compared to other metals. Most metals are quite a bit more dense, and that's why we use aluminum for many applications, because of its low density. Now how about something like this? Here it says the density of mercury is 13.53 grams per mil. It's a liquid, so we express it in milliliters. What's the mass of a sample of mercury if you have 25 milliliters of it? So in this case, we're asking to solve for mass. Now if you remember the equation rearranged, the original equation is density is mass over volume. Rearranged equation is mass equals density times volume. Remember, we moved the volume out to this side. So we simply have to multiply the two values. Now this here is our density, and this here is our volume. So our density is 13.53 grams per milliliter. We'll multiply that by, and the parentheses mean multiplication, by our volume, which is 25 milliliters. So go ahead and in your calculator, plug this in, 13.53 times 25, and you should get yourself 338. So 338. Now, without explaining why, I'm actually going to round it to 340. And we'll tell you the reason for why it has to be rounded. The question now is, what are my units? Well, it turns out that the milliliters will cancel out, because milliliters appear on top and on the bottom, and so grams is left. And that will be my unit. 340 grams is my answer. And that matches because we are asked for the mass. Since we're solving for the mass, that matches the mass. One more example. Example 3, iron's density is 7.87 grams per milliliter. How much volume will 55 grams of iron occupy? So in this case, we'll need the equation that solves for volume. And if you remember, the volume equation, the original equation is density equals mass over volume. What we did is we moved volume this way, and we moved density down here. So volume equals mass over density was our equation. So our density is here, our mass is here. Let's just plug in and see what we get. The mass in this case is 55 grams. The density is 7.87 grams per milliliter. Now notice we are using milliliters even though it's a solid, because remember, centimeters cubed and milliliters are equivalent. So don't be upset that we're using milliliters for a solid. It's allowed. Okay, well, let's go ahead and divide those two numbers. 55 divided by 7.87, which gives us 6.988. Now again, I'm going to use two numbers, so I'm actually going to, so 6.988 gets rounded to 7.0. I just need two numbers in this case. Now if I need two numbers, then this becomes a 0, and means this becomes a 7. So my answer is actually 7.0. Now the units, if you take a look, same thing happens. The grams now cancel out, and I'm left with milliliters. So my units will actually be milliliters. And that's what I want, because volume is what we're asked for, how much volume. You could have also said 7.0 centimeters cubed, because remember, a centimeter cubed is the same thing as a milliliter. Hopefully that made sense. Go ahead and try these two problems on your own, and then we'll see you in class.